Let's do it. So hi everybody. This is a presentation of the Jacobs 1A report and its associated appendices. The information given during this presentation comes from the report that is available on the Newman Lake website. Our goal is to walk through the report and try our best to answer any questions you may have. These are Jacobs' findings and study, so we can only speak to the information given to us per the report. We have broken down this presentation into 6 different sections to help highlight the key items in the report. We'll start off with an introduction to talk about the study's goals, some background on how we got to where we are now, and a review of our existing water quality system. Then we'll talk about the physical condition of the system by reviewing the dive inspection and site visit findings. Next, we'll talk about the operational efficiency of the system and evaluate the options that Jacobs proposed to improve the system's efficiency. After that, we'll talk about Jacobs' recommendations for moving forward with the capital budget project. And lastly, we'll talk about long-term considerations that Jacobs recommends that are outside the scope of this project. To help remind everyone on how we got to today's presentation, here is a timeline of what has happened so far in the project. A request for qualifications, or RFQ, was sent out on May 20th. The RFQ contained a scope of work that detailed the objectives of the grant project and what tasks we expected a bidding consultant to perform. The RFQ closed on July 1st, and a selection committee was formed to review the submittals from the RFQ process. That group met on July 22nd and July 27th. Once the committee had chosen the most qualified consultant, the selection was brought to the Board of County Commissioners for approval on August 18th. A kickoff meeting between the county and the chosen consultant, Jacobs, happened on August 19th, and follow-up meetings happened on August 25th and September 9th. A finalized scope of work and budget was completed on October 19th, and work on Phase 1 began shortly after. Since then, Jacobs has worked on collecting data and putting together the Phase 1A study report that we're going to go over today. There were 2 main goals for the Phase 1A study: determining the inefficiencies and problem areas associated with the existing oxygen and alum systems, and getting recommendations for improvements to address those problem areas. It's important to remember that there are clear limits as to what the state capital budget grant award money can be spent on. These limitations were laid out in our application for the project's scope. If a recommendation did not fit within that scope, then it was not considered an option for this project. To put the Phase 1A study into context, let's take a look at the existing water quality system. We're going to focus mainly on the oxygenation system, as that was the main focus for this study. The equipment under the lake includes the species cone that was installed in 1992, the distribution pipe, and the in-lake pump. The onshore oxygen generation equipment originally had 2 AirSub 1000s installed in 1991. We replaced one of the AirSub 1000s with an AirSub ASL model in 2016. Both AirSubs are supplied with air from 2 air compressors. As you can tell, some of our equipment has been in operation for almost 30 years. This picture shows the compressor building right up here where the onshore equipment is stored, and the oxygen travels to the species cone through the in-lake pump and gets distributed along the distribution pipe shown here in the photo. I'm going to leave the site up for you all to take a look at it a little bit longer, and we'll take some questions if anyone has any about any of the information that we've presented so far.
And as a quick reminder, any questions, you can go ahead and put those right into the chat box, and we will be watching for those as a team and answer them as we go. Just wanted to let you know. Thanks. Sorry, I mean the question and answer box versus the chat box. I apologize. Question and answer at the bottom, Q&A. Thank you.
It looks like, as far as I can tell, there aren't any questions so far, so we're going to move on. Next, we'll talk about what the dive inspection and site visit findings told us about the physical condition of our equipment. Those findings help lead us to understand the operational efficiency of our equipment. I was with Jacobs for both trips out to the lake and operated the equipment while they did their work. We're going to start with the dive inspection that happened on October 27th. I met with 3 of Jacobs' divers and took them on the boat out to our Spees Cone. There, they conducted an inspection of the structural elements of our underwater equipment. Their objective was to know any obvious defects, damage, and deterioration on our equipment, and they also measured the thickness of the steel on some of the elements. During the dive inspection, I only had one air sup on in operation due to safety concerns that were brought up during our pre-dive meeting. Per the dive inspection report, the system is in overall good condition. The table here shows the condition ratings that the dive team issued to the different elements of the in-lake equipment. The structural systems are performing as designed with minor to moderate deterioration. There are no leaks observed, but undissolved oxygen bubbles were seen discharging along the distribution pipe. Those oxygen bubbles rise from the distribution pipe and create the bubble plumes that you see at the lake's surface. Moving on to the site visit, Marianne and I met with Jacobs' technical task lead engineer, a Jacobs employee who works as the lead mechanic at Spokane County's Regional Water Reclamation Facility, and Joe Hennessy, our air sup consultant. We turned on all of the oxygenation equipment and took everyone out on the boat to observe the bubble plumes. Then we came back to the compressor building to talk about the equipment's history and potential construction possibilities, like how we're going to remove and replace the equipment that we are planning to take out as part of this project. After the site visit, Jacobs reached out to Rogers Machinery to get more information about the condition of our equipment since they do the maintenance on it each year. Rogers told Jacobs that the compressors were at 70% or roughly 70% of their useful life. Joe Hennessy checked with AirSup and noted that there are no longer spare parts available for the AirSup 1000 model. The site visit also provided an opportunity to get a better idea of where a new pump housing structure could be installed. One of our original goals for this project was to explore the feasibility of adding a new pump housing structure that would be easier to access and maintain. This idea would help save the district money by removing the need to hire a diver to service the in-lake pump underwater. Jacobs provided 2 options in the report appendix, either onshore or on a platform in the lake. After discussion about how those structures could be constructed, he mentions in the report appendix that there does not appear to be a strong technical benefit of a new, more accessible pump station. To Jacobs' knowledge, there is no other Spees Cone application that has an in-lake pump platform like the one we're proposing. This concept would also require design development to assess the feasibility, as well as additional permitting and easement requirements that we would have to obtain. Bubble plumes were also observed during the site visit as they were during the dive inspection. Those plumes were created from the undissolved oxygen bubbles, and we will get to why we have those undissolved oxygen bubbles leaving our system later in the presentation. The group also looked at the alum injection system during the site visit. Jacobs recommends that we replace our current pump with one that can produce higher pressures. These high pressures could potentially be used to blow out any clogs in our system, making our clogging issues less likely in the future. Along with that idea, Jacobs recommends replacing our current alum lines with ones of a larger diameter that would be strong enough to withstand the new pump's pressures. As far as the alum tank replacement goes, Jacobs recommends that we contact the tank's manufacturer and ask for an inspection to get a better idea of what type of tank would best suit our project needs.
Hey everyone, my name is Dawson Matthews and I am one of the other staff engineers for Spokane County and for the Newman Lake Flood Control Zone District, and I'm just going to talk a little bit about the operational efficiency. So after Jacobs completed the dive inspection and the site visit that Malcolm just discussed, they worked on a simulation or a model of the existing water quality system to determine its capacities and kind of where we were lacking in efficiencies. And so what they found is captured in this statement, which is directly pulled from the Jacobs report. And I'm going to read it to you directly. It says the required oxygen demand is close to the current oxygen generation capacity. However, the in-lake Spokane HOS or hypolimnetic oxygenation system is only able to deliver about a quarter of the oxygen demand. So what that actually means is that the required amount of oxygen for Newman Lake to theoretically stay healthy and not become depleted of oxygen in the lower levels, it can be supplied by the oxygen equipment on the shore of Newman Lake. So the compressors and the air seps that Malcolm had mentioned earlier. However, the delivery system, so the equipment in the lake, the speed cone and the pump, they can only actually effectively transfer about a quarter of the provided oxygen. So as Malcolm mentioned, and what was observed in the site visit and the dive inspection, there was bubbles, and that people can see in the community on the lake. So what that is that's basically the speed cone cannot effectively dissolve all of the oxygen that's being supplied to it. And Jacobs determined that the entire water quality system as originally designed, it actually could never supply the required amount of oxygen to Newman Lake. And that is, as Jacobs noted in the report, that's actually due to kind of a lack in some of the new scientific knowledge that is associated with water and hydrodynamics of water. So it's not a fault in the design necessarily, it's just new improvements in our scientific understanding show us that it was never possible to deliver the oxygen that we were supplying to the in-lake equipment and provide that to the lake. So Jacobs found that there are kind of limited options to improve the operational efficiency of the existing system. And I'm going to hand it back over to Malcolm to discuss what those options are here in the next few slides.
And I apologize for not introducing myself at the beginning and just barreling into this presentation, but my name is Malcolm Hamilton and I am another Newman Lake engineer that works for Spokane County. But before we move on to the next section, does anyone have any questions about any of the information so far? All right, it looks like we have our first question. Where in the report does it say the estimate kilograms per day of our system produced in 2020?
I can jump on that. There's nowhere in the report that I've been able to find that it currently directly says this is exactly how much is transferred to the lake. That wasn't actually something that they studied. They looked at the theoretical capacity that it could supply. And with the current operational parameters and the conditions that we have, it states in the report that is 600 kilograms per day. But again, that's not directly discussed in the report. It's kind of, I would say, mentioned broadly.
Thanks, Dawson. Our next question, is the turbulence produced by the bubble plume partially responsible for the early seasonal turnover of the lake? You mind taking this one too, Dawson?
Yeah, I can jump on this. So this is not something that any of us can comment on. There's no Jacobs did not discuss that in the report, and they told us that in order to make a comment and a scientifically informed decision and conclusion on that would require a larger study. They said that the only thing that they were willing to make a comment on is there could be very localized mixing caused by the equipment, but there's no way to know without a larger study if that could affect the entire lake. So again, there's not really an answer to that question from this report.
Thank you, Dawson. One last call for questions before we move on.
Yeah, and I also want to put this out there for the first question that we had about where in the report does it estimate the kilograms per day of the system in 2020. That was not something that Jacobs was really tasked to do. They were supposed to look at the efficiency of kind of the capacities of what it could do. So that's why it's not directly discussed in the report.
Seeing no other questions, we're going to go ahead and move on. Based on the findings of all the data collected, Jacobs came up with two options that fit within the grant scope: modify the existing system or upgrade the system. The objective of option 1 is to modify the existing system. This option involves replacing the in-lake pump with one that produces lower flows. This option also replaces the AirSup 1000 and both compressors with newer models. The Spokane output for this option is estimated to be about 600 kilograms per day, the estimated max capacity that our Spokane can currently handle. This 600 kilograms per day can be supplied by operating only one set of AirSup and compressor units. While this option won't prevent oxygen-deprived conditions in the lake, it may offset it by 30 days. Option 2 is designed to upgrade the existing system by replacing the pump with one of lower flow capacity but higher pressure output. The AirSup 1000 and both compressors will be replaced with newer models in this option as well. The higher pressure from the pump will be combined with the installation of a pressure restriction plate to raise the pressure inside the Spokane. This will result in an estimated higher Spokane oxygen output of approximately 870 kilograms per day. That amount can also be supplied by operating only one set of AirSup and compressor units as well. This option won't guarantee that oxygen-deprived conditions will be prevented, but it may delay it until September.
Yeah, so as Malcolm just discussed, Jacobs found that option number 1 would produce an estimated supply of 600 kilograms per day of oxygen, and option number 2 would produce an estimated supply of 870 kilograms per day of oxygen. Jacobs also stated in the report that the estimated oxygen demand of the lake for comparative analysis purposes, they found that to be 950 kilograms per day. And in the report, they refer to this, for those folks who have read it or haven't, they refer to it as hypolumnetic oxygen demand, or HOD. And it's basically the amount of oxygen that all living creatures, basically in the lake, like fish and other microscopic organisms, that they consume in the lake in their living processes. So what you see here in this graph It's a representation, a visual representation of basically the water quality benefits of both of the proposed options that Jacobs put forward. And it's kind of shown on a timeline of a typical spring through fall operational period. You can see that the colored data points, those are actual field data collected, dissolved oxygen data collected back in 2014 and 2015. And then the solid line that's kind of overlaid on top of those, that is the 950 kilograms per day. That's an oxygen depletion rate that Jacobs used in the report for a comparative analysis. And then the other two lines, the dashed line in the middle and then the dotted line farther to the right, those are the oxygen depletion rates relative to each proposed option. And so option number one is shown on the bolder dashed line in the middle. And this option would theoretically extend oxygenated conditions in Newman Lake for about 30 days compared to not having any water quality system in the lake. Option number two, shown on the dotted line on the far right, this option would theoretically extend the oxygenated conditions into the fall turnover period when the lower levels of Newman Lake are typically, we see that replenished with oxygen from the turnover. Again, it is important to note here that these are model scenarios and they were not able to take into consideration all of the, wind mixing and different temperatures and all of that sort of stuff that each year brings. So they're only an approximation of kind of the water quality benefits of each option that they proposed. So yeah, now I'm going to turn it back over to Malcolm, and he is going to discuss the Jacobs recommendations.
Thanks, Dawson. So based on those two options, Jacobs recommends that we move forward with option one as it is the most reliable choice. Option one provides cost savings since future operations will only utilize one set of air sep and compressor units at a time, as opposed to using both as we have been in the past. The use of a smaller pump will also add to the cost savings. This option also has a lower risk than option two. Option two's design requires increasing the pressure inside the species cone. Unfortunately, the species cone does not have a pressure rating, so raising the pressure could be dangerous and may cause the seals to fail. Additional funding would be required to perform a study to determine the risks associated with option two. Going back to option one will add reliability and redundancy for the onshore equipment that can be utilized in future long-term upgrades. Jacobs also recommends taking a look at extending the operational period of our water quality system to gain additional lake health benefits. This will be discussed during phase 2 to see what changes to our operational schedule Jacobs recommends. An extension of our operations may offset the cost savings that we gain from running only one air sep and compressor unit. Lastly, option 1 fits within the scope and budget of the award and is likely to fit within the capital budget grants allotted funds. With that, we are going to take questions. And I didn't mention it in the comparison of the two options, but the reduction in flows for the in-lake pump will help reduce the undissolved oxygen bubbles that create those plumes at the lake surface. So our first question is, where do you think the 2020 actual oxygen supply was between the solid line and the heavy dashed line? Based off this graph.
Yeah, so that again, like we mentioned, that's not something that we asked Jacobs to look at. So we don't actually know the supply, or I should say, we don't actually know the transfer rate at which how much oxygen was actually absorbed into the lake. So I'm not willing to make a comment on that. Yeah.
And I'd just add to that, this is Colleen. So we never asked them to look specifically at any given year. They were tasked specifically with looking at, what is the system capable of doing onshore and in the lake? And what can we do to make the system operate more efficiently? We didn't ask them to look at a specific year, so they didn't provide that information, and it really wouldn't be appropriate for us to guess what we think. And I'm sure if we asked Jacobs this question, they would say they don't know either. So I apologize, we don't know the answer to that question.
All right, our next question is how much money will be saved each year by running just one air sup in option 1? Could we use that savings to treat with additional alum? I do not have any approximate numbers as to how much our electricity bill would be cut down by using only one air sup and compressor, but I imagine like roughly 35% estimate, just because you have like continuing costs of keeping the lights on, keeping the heaters on, that won't change between the years. But yeah, reviewing that, it should go down a sizable amount. And could we use it to produce or treat with additional alum? It's a possibility. I don't make the budget. If Colleen wants to jump in and answer that question, but the cost can be used to further.
Yeah, I think that one of the recommendations that Jacobs alluded to in the report was that there may be some additional lake health benefits gleaned from taking a look at, if we go forward with option 1, would there be benefits of running the system longer, running parts of it in parallel? And, they really want to explore that, and we do too, because if we're going to kind of ratchet the system back a little bit so that both the in-lake and onshore kind of match each other better, then if there are benefits to be seen by running the alum sooner and longer, or the oxygen system, we don't know the answers to those yet. But our guess is, without running any numbers and knowing what that new ops plan looks like, we couldn't answer that question directly, Leanne. But if obviously there's going to be a big savings from only running one air sep and one compressor, so potentially that cost savings could be, I don't want to say lost, because you would just be spreading out what you normally spend in a year, but you'd be spending it in a different way. So yeah, purchasing more alum, running the oxygen system, longer, those, it might end up being a wash. But again, until we see what their recommendations are for, a different or seasonal operational plan, we wouldn't be able to put numbers to that just yet.
Our next question, request is, can you review the cost and construction risks associated with the unknowns in option 2? We don't have exact numbers, but I can kind of run through what would be, I guess, required for option 2 that would lead to additional costs. So for option 2, replacing the in-lake pump would be the same for both options, but the installation of doing underwater construction to add that pressure restriction plate also adds money. So that alone, without having to, that cost plus the study to determine how high can we raise the pressure safely in the space cone, would kind of make a giant, I guess, budget that we need to come up with just to even discuss this feasibility.
Yeah, also to add on to that, is the dive costs is really an unknown, how much time is going to be down there. And once you start opening things up to review the possible pressure increases, there's unknowns that could be found, which could lead to possible more costs. So that was something that Jacobs said multiple times in meetings. That's something that they were very cautious of,
And also just to tag on to that a teeny bit, I'm very practical, and Jacobs also had said to us that, you know, if perchance, you know, there had been, you know, maybe an increased support to look harder at option 2, he said, you know, we don't know how much that study would cost, but conceivably you could spend a bunch of the money in this grant to explore, you know, whether or not this risk to breaking things under the water is going to happen or not. And you could, you know, conceivably come to the end of a very expensive study and find out that option 2 would, you know, break the equipment. And so then it's no longer an option. And now you've already spent a bunch of money, you know, and you would have nothing, we wouldn't have much money left over to actually do something in the lake. So that also is part of why that option 2 is just not, you know, not really an option at this point.
We're going to do one last call for questions before we get to the conclusion of this presentation. All right, so while option 1 will help make our operations more efficient, Jacobs recommended another advancement in lake health technology for us to consider in the future.
Yeah, so Jacobs was able to offer some of their expertise. They have a lot of wastewater and water quality treatment experience, many years through many projects, and they were able to use that to kind of evaluate in a completely different system than what's currently in the lake, called a pure oxygen line diffuser. And they say that this should be considered for future replacement of the Spokane and the whole water quality system. So basically what a line diffuser is that it's a long pipe placed in the bottom of the lake. In the report, they say it would need to be about 2,000 feet long, and it would discharge pure oxygen directly into the deepest water column of the lake. And it's really very small bubbles that would be discharged into the water. And because they're so small, and there's some hydrodynamics that work along with that, but it would be able to dissolve up to 90% of that oxygen into the water. This is pretty new technology. It's emerged in the last 20 years, and there's about 36 projects in operation throughout the US. Now, the cool thing about this is this system would lower operational costs compared to the current water quality system operations due to the lower energy costs. So it would only require 1 air sep and 1 compressor, and also less equipment. So because the compressors and the air sep, that whole combination has enough pressure to supply the oxygen to the line diffuser, there wouldn't be an in-lake pump required. So the cost of that goes away, and any servicing, and then also the electricity cost of powering the pump. Furthermore, the line diffuser also would be able to utilize the existing equipment and the proposed onshore water quality improvements through this grant. So whatever, you know, fixes of the compressors and air seps, that would be able to be utilized in future planning down the road for direct implementation of the line diffuser. However, and here's kind of the snag on it, it does not fit within the capital project scope or budget, and it's therefore we're not able to consider it right now as a feasible option for this project. However, we are already looking into the scope and kind of looking into how much it would cost to develop a scope and budget to figure out how to implement this system, years down the road. But we're really grateful and happy that Jacobs was able to offer their expertise on the line diffuser and provide the district with a long-term in-lake water quality system plan that theoretically could handle all of the in-lake nutrient recycling issues that contribute to poor water quality, which is really exciting. So yeah, I'm gonna hand it to Colleen and walk through kind of the next steps of the project. Do we want to pause for a question before this, since it's kind of related to the line diffuser?
Sure.
Okay. We got a question. It says, is it the district's opinion that using a line diffuser would necessitate removal of the species cone and distribution manifold?
I'll take that one if you don't mind, Dawson. So we did talk about this at length with Jacobs, and because it is about $50,000 to $75,000 to take all that equipment out of the lake, obviously that would be a huge cost savings if we could just ignore it. The problem is that we now have an easement that we probably should have had for years with the Department of Natural Resources in order to keep, operate, and maintain that equipment in that location. So once that equipment is non-operational, it's pretty certain in my mind that Department of Natural Resources isn't going to just let us leave it sit in the lake. The easement that we signed was like 35 pages long. It had lots and lots of boiler template language. And yeah, I can't even contemplate, them saying yes to letting us leave it there. And, the more we talked about it, it seemed like it was a hazard to leave it in the lake. So yeah, it's not necessarily the district's opinion. It's just kind of a fact that DNR is not going to let us leave it in the lake because it's no longer meeting the criteria of the reason that it is in the lake, if that makes sense. Hopefully that answered your question. All right, so what are the next steps? Probably everybody's pretty interested in this. So the phase 1A Jacobs report, we just covered that. And only as way of explanation, phase 1A sounds like, so what's the 1B? As we were originally developing the scope and budget with Jacobs, we knew that until their analysis was done and we really had a better idea what direction we were heading, we didn't even know if the idea of a new pump housing structure to save us money on diving was even possible. So as Malcolm alluded to earlier, Jacobs already decided early on that this probably just wasn't going to work for us. And another reason is it would require yet another easement from Department of Natural Resources for us to locate it on the shore, probably a big environmental, impact type study. And could we even get an easement from Sutton Bay Resort? Yeah, and floating on the water as a big structure is a navigation concern. And so DNR might not have even processed the easement. So we really just decided to save the money in the grant and not go any further with that. So phase 2, obviously, is the best and most important piece, which is the implementation of these findings and recommendations. So we're already in coordination with Jacobs right now to get together on a new scoping and budget meeting. We've developed a list of, what we need from them moving forward and just exploring ideas of how we can save money. But ultimately what they are going to be responsible for is helping us get ready to put things out to bid and, get rolling on the project. So our timeline goals and a couple of the challenges. I wanted to run through that too. So working with any consultant developing a scope and budget takes about a month to 6 weeks turnaround time. Obviously, we're going to move fast. Maybe it'll happen a little faster, but there are steps we need to go through with them before they're comfortable to just dig in and start working. We will need to chat with Jacobs on the timeline of how long it will take to prepare the plans, specifications, and estimate for this next phase, and even how much do we need from them all together. And then the part that does go out to bid, it is about a 10 to 12 week Spokane County process. Really no way to get it shorter or less than 10 weeks. There are public notification and advertisement criteria, and Board of County Commissioners approval to go to ad, just all sorts of steps in the process to get from day one to breaking ground is about 12 weeks. And then one thing I just wanted to touch on was, although we're feeling super positive and excited about moving forward with option one, with the goal to complete the water quality improvement projects that have been suggested by Jacobs in 2021, we don't see a timeline or schedule conflict with that at all. But one of the things that Jacobs discussed with us was the very unique nature of this project in general. That there are very few contractors in the United States who are familiar with our type of system and who would even be interested in bidding on performing the work for this type of system. So while we're apt to get bids from qualified people, because not very many people are going to even be interested in this because they aren't going to know what it is, it could also go, in an opposite direction, which is that, and we find this in road construction sometimes too. You may get a single lone bidder and their price might be far outside what the grant award has allowed for. And maybe that's due to travel time from wherever they're located. It's hard to say. So it's just, not trying to scare anybody off, but just trying to let people know that although we're moving forward and, zero delays, just let's see if we can't get this done this year, we don't control the bidding climate and don't really have any control over the outcome, but we'll be sharing that information as we go along, at every step of the way. So at the conclusion, assuming we get to do all the things we want to do this year, at the conclusion of this season, all the water quality stuff is in, running and working, then we'll have to take a look at what's left in the grant award, because there will be another consultant fee cost with Jacobs this next phase, right? So we'll have to go back to our list of what did we apply for money for, and, take a hard look at what those things may cost and do a prioritization of what's on that list to go ahead and get that completed in 2022. And I doubt that we're going to need Jacobs for anything in the flood control. We won't. We can handle all of that in-house. So anyway, that's where we're at. And again, open to take any questions on the timeline or anything else that we've said thus far today. Okay, there's a question that's, can you share how many people are logged into this call or presentation? There are 22 people in the participants queue. I think 5 of those are our conference rooms and our staff. And then it looks like maybe most of the people are either current or past advisory board members, but there's a handful, maybe 6, 7, 8 people that are appear to be community members that are in attendance. Is that helpful? Okay, so next question is, so how do we operate our system until the Jacobs project is to begin phase 2? Well, we are currently, operating the system as if normal, because we wouldn't want to miss the window of alum injection, and Malcolm has already been in contact with Thatcher, who is our alum supplier, and because the weather outlook the next few weeks is pretty good, it's meeting our operational parameters here quickly as far as getting alum in the lake. So we're going to obviously just continue to operate as normal until we're, you know, working in phase 2 with Jacobs, and that will be part of their scope for phase 2, is to lay out what is the best plan and window for doing the work in the lake and having things shut down for as little time as possible, and then getting it fired back up. They're the experts here, so we will defer to them. But in the meantime, you know, until we're actually have a contractor under bid and are ready to roll, we will just keep operating the system as normal. Next question is, let's not forget that the aerator alum system deals with the nutrients in the lake. What is being done to prevent those nutrients from entering the lake and re-entrainment from the lake sediments? I'm going to let Dawson take that question.
Yeah, that's a great question. It's actually really exciting, all of the things that are happening out at Newman Lake, because it is definitely, you have the, like you said, there's the issue of in-lake nutrients and recycling, but there's also the issue of inputs from outside of the lake. So a couple projects that are happening right now, Spokane Conservation District, they are doing, I think they're still in the process of their wake study, looking at erosion from waves around the lake and how it's eroding the shore. They also are still working on their septic feasibility, if you will, study. They were at least listed on the preliminary funding list for Department of Ecology for a very large grant, $500,000 grant for Newman Lake to continue their work out at Newman Lake with education and also implementing more of the septic systems. And then a local conservation group called the Lands Council has kind of partnered with the Property Owners Association, Newman Lake Property Owners Association, as well as Gonzaga University. And they're working with a local landowner on just north of the lake, right there on Thompson Creek, where it comes into the lake. You know, and according to the Department of Ecology's 2007 TMDL, that's the largest contributor of sediment and phosphorus to the lake. So they're actually working on a really cool plan. They put together a monitoring plan. They've done baseline monitoring for sediment and phosphorus, and as well as some other macroinvertebrates. And they are working on a project to basically trap sediment within the stream and prevent it, or at least prohibit it for a while from going into the lake and basically letting it spread out into the floodplain there. So it's a really super cool partnership, and lots of hands and lots of funds allocated towards that project that has some really great potential. So there's quite a bit going on, and that's what we really love to see, is all the partnerships at Newman Lake and the different agencies and community members involved in this sort of thing, so we can tackle the issues we see. So great question. I did want to mention though, the last question, Colleen, that you had answered about how do we operate our system until the Jacobs project is able to begin phase 2. I guess I wanted to kind of clarify on that question. I didn't know, maybe they were hinting at, should there be any changes to the way that we currently operate?
That brings us up to one of the next questions on there. Okay. Yeah, and that's way down the list, but let's just jump there. The question says, since Jacobs has agreed that we far overdrive our system, Why would we want to run as normal when we absolutely know that running one compressor and one air sep is far better for absorbing oxygen in our species cone? So my answer to the prior question about running as normal, that I didn't necessarily mean that. What I meant is we're not going to wait and not start our normal seasonal operation. But yeah, it probably does make sense to run one compressor and one air sep. And that'll be a conversation that we'll have with Jacobs too. But I suspect that's the direction that we're going. We don't actually start the oxygen system for quite another month and a half or 2 months. So we have time to sort that out. But yeah, I didn't mean to imply that we were going to do 2 air seps and 2 compressors. I just meant we're not waiting. We're going to continue to do what we need to do for lake health while we're queued up for this plan. Hopefully that answers that question. Then there was another question that is, can we utilize the grant money to go forward with the future considerations and start to obtain future grants? Unfortunately, we cannot. State, and if I don't answer this well enough for you, I'm going to let Ron Valencia from the Commissioner's Office jump in here. But this was a very specific capital grant that we applied for funds, quite some time ago, based on a wish list from help from the advisory board. And, we put dollar amounts to it. At the time we applied for this grant, we didn't ask for the option to introduce new technology, which is what the line diffuser is. We all made the assumption, every single person, that after this analysis and study by the consultant, they would have been able to give us recommendations to update, repair, tweak, modify the system that we currently have, so that the onshore and in-lake systems match one another. And that is not the answer that we got in the end. And, so no, we are unfortunately obligated to stick within the parameters of what we asked for and what we were granted the money to use it for. So hopefully that answers your question. The next question is, a pure line diffuser dissolves up to 90% of the oxygen into the water. If option 1 is chosen, what % of the oxygen will be dissolved into the water? We don't have that answer right now, but that's what a consultant would answer that. I don't know, Dawson, do you want to weigh in here? But that isn't a question that we as district staff are going to have the answer to.
Yeah, I mean, I can't give a solid number, but I do remember discussions of that with Jacobs, and it's not going to be 100%, but if you do put in a new pump to lower the flow rate, and you're supplying less oxygen, and you have it dialed in with the right pressures, theoretically, you would, in a perfect world situation, you would probably see close to 100% transfer rate. But they did say that basically there's going to be it's random bubble plumes, so there's going to be oxygen loss, and that's I think they're estimating that between 5 and 10% or so. There's been kind of different numbers thrown around, so yeah.
Right. Let's see. Sorry, I was off the page for a moment. All right. Well, I think it looks like we've answered most of the questions. I don't see any new ones. Let's see. Are there Any additional closing questions? I think our final number of attendees for the person who asked, it says 23 now. So again, 5 of those are district staff.
I do want to go back to that last question. It does in the report, it says approximately 5% of the rate that could be lost. And that's just due to the basically random bubble swarm that happens. And they are, that's not a guaranteed 5%, it's plus or minus who knows how much because things are random. So yeah.
So I just wanted to mention too, before closing out the meeting today, the meeting is being recorded. And so the video, there will be a video associated with the presentation today with all of our questions and answers. We will put that out on the Newman Lake Flood Control Zone webpage and also make it accessible if Advisory Board Chair Karen Stebbins would like to share that with the various associations that she has contacts with and the Newman Lake Flood Facebook page, things like that. Any place you want to put it, we're happy to make it available to you all. All right. Well, thank you very much for everyone attending. And if you have any follow-up questions that you'd like to ask the team, you think about later, we're happy to field those questions. So thank you.